Shirdi, sir.
Okay, you are in Shirdi, yeah. Okay, okay. So when you are going to return?
Tomorrow or day after?
My here two samhitas are there. Okay. And one more is new girl, Lama. One more samhita.
Yes, sir.
Ma, at least we had to tell her from last 3 days. I am thinking that old student only. Okay. So I'm getting a little bit confusion. Samhita, if you don't mind, at least can you place your initial? Then only you'll get the clarity.
Yes, sir.
Yes, sir.
Okay, ma. Any one of you, please keep your initial in starting. Okay. So Samhita, new one, ma. So you are from which school? Which college?
Ignite, sir.
Ignite. You are from Hyderabad.
Yes, sir.
Okay. So from last 3 days you are attending the classes, but I'm considering old student only. Okay. I don't know. Yesterday Sir told that sir one more Samhita also it is there. So better to interact with her means here. So then only I got the clarity. Until that I didn't expect. Samhita is getting some network problem. Whenever you are having network problem, is 2-3 links it will come at a time. That only I consider.
Yes, sir.
Okay. Okay, ma. So in last class we had seen some basic concepts of the chemistry. In that one last part we had to do some numericals. Okay. And how many members you are solving the questions from the some basic concepts of chemistry? All of you tried any questions from some basic concepts of chemistry?
Yes, sir.
On mains level? Okay.
Yes.
So keep on practicing the question. Just I'm going to deliver the concepts only. Okay. And wherever the important numericals are required, there I'm going to be explaining. Okay. If you're having any doubt also, you can WhatsApp me, Mama, here. Okay. So whenever I'm having the free time, I'm going to be discussed with you. Right? Otherwise, so while class time only, we can discuss that questions. Is that clear? So anyway, good number. So today also 4 members are they joined. Samhita, Sriyuta, Javian.
Good evening, sir.
Good evening, Javian. So how are you?
I'm good, sir.
So you're from which college?
Sir, I'm in North Hills from
You're from
Bangalore.
North. So another location?
Yes, sir. I'm in Bangalore.
Okay, okay. So you also completed, you are also preparing for the JEE.
No, sir, I'm not preparing for the JEE. I'm preparing for Comet K, and there's a theory called AME-CET, which is like based on aeronautical. So I'm
Okay,
preparing for that.
okay, okay, okay. You are preparing for chemistry. You are applied for the aeronautical engineering. For
Yes,
aeronautical
sir.
engineering, also physics and chemistry, maths.
Yes,
Maths
sir.
also. Okay, so maths also is that. Okay, right.
Yes, sir.
So Javian, so we already completed some basic concepts of chemistry. So related that one, you can go through our videos also. Okay,
Sure, sir.
so
I will do that.
yeah, so which is available in the app. Okay, so today we are going
Yes,
to
sir.
discuss about the redox reaction, which is interlinked to the some basic concepts of chemistry. Okay, so first of all, what is mean by the redox reaction? Redox.
Oxidation and reduction happens at the same time.
Okay, so what is mean with the redox reactions means redox reactions are nothing but here in a chemical reaction, both the oxidation and reduction reactions are will takes place simultaneously is called redox reactions. What is mean with the redox reactions means here in a chemical reaction, both the oxidation and reduction reactions are will takes place simultaneously is called as here redox reactions. Okay, so before that, first of all, sir, you are telling that oxidation and reduction. What is mean by the oxidation? What is mean by the oxidation? What is mean by the oxidation? So what is meant the
Adding
oxidation means? We
ox-
can give some different definitions. We can give the different definitions for the oxidation. What are the different definitions we can give? The oxidation means here addition of oxygen. Addition of oxygen. Okay. And second one, removal of hydrogen. Removal of hydrogen. Removal of hydrogen. And third one, okay, so removal of electrons. Removal of electrons or losing of electrons. Losing of electron. With respect to the electrons, losing of electrons or removal of electrons also we can call it as a oxidation. And what is the another definition we can give means here increasing of oxidation number. Increasing of oxidation number. Increasing of oxidation number is called as a oxidation reaction. Okay, and second one here. So what is the another one means here? Reduction reaction. Reduction reaction. So what is mean by the reduction? So what is mean by the reduction means here exactly opposite statement. What is the opposite statements we can write means here addition of hydrogen. Addition of hydrogen. Addition of hydrogen. And what is the second statement means here? Removal of oxygen. Removal of oxygen. Removal of oxygen. And what is another definition with respect to the electrons? How we can define the reduction reaction means here gaining of electrons. Gaining of electrons. So gaining of electrons also we can call as here reduction reaction. Okay, so gaining of electrons also we can call as here reduction reaction. And what is the another one means here decreasing of the oxidation number. Decreasing of oxidation number. Decreasing of oxidation number. So decreasing of oxidation number is called reduction reaction. Okay, so all of you know you got one clarity. What is meant by the oxidation and what is meant by the reduction? Everyone, you got clarity here?
Yes, sir.
All of
Yes,
you got
sir.
the clarity? Okay, next. Here, another words also we are using in this one here. So what are the other words we are using means here? What is mean by the oxidizing agent? What is mean by oxidizing agent? Oxidizing agent. Okay, actually everyone they used to get as a confusion. So that's why I want to clear here only. Okay, what is mean by the oxidizing agent? Oxidizing agent means the substance which it undergoes the reduction reaction is called as a oxidizing agent. What is mean the oxidizing agent means here? The substance which undergoes reduction reaction. The substance which undergoes here reduction reaction is called as here oxidizing agent. Sir, what are the examples of the oxidizing agents which you know already you studied +1 and +2? So what are the examples of the oxidizing agents are there here? What are the examples of the oxidizing agents? Is any examples?
KMNO4 H2SO4.
Very good, Samhita. Okay, so KMNO4. Okay, in this one also acidified KMNO4, alkaline KMNO4 also it is there. So alkaline KMNO4 is called as a Bayer's reagent. Okay, alkaline KMNO4 is called as here Bayer's reagent. Acidified KMNO4 also, and acidified K2Cr2O7. All these are we can get in organic chemistry. Okay, acidified potassium dichromate. In this one, HNO3. Nitric acid also it acts as an oxidizing agent, and sulfuric acid also it acts as an oxidizing agent as well as okay dehydrating agent also. Sulfuric acid also it acts as here oxidizing agent as well as here dehydrating agent. Okay, and along with that one some other reagents also it is there. Sir, what are the other reagents we are having means here One is chromium trioxide, okay, and PCC and PDC, John's reagent, okay, Collins reagent, So all these are the examples of the oxidizing agent. In this one, acidified KMnO4 and acidified potassium dichromate are we can call as a strong oxidizing agent. Okay, acidified potassium permanganate and acidified potassium dichromates are we can call as here strong oxidizing agents. Okay, strong oxidizing agents. So now we got the clarity. Okay. So all of you got the clarity here. What is meant by the oxidizing
Yes,
agent?
sir.
The substance which it undergoes to the reduction reaction is called as a oxidizing agent. Sir, what are the examples of the oxidizing agent? Means KMnO4, K2Cr2O7, HNO3, sulfuric acid, CrO3, PCC, PDC, John's reagent. So all these reagent where you use means here in aldehydes and ketones, alcohols, phenols, ethers chapter also we used all these reagents here. Because of alcohol, in the conversion of alcohols into carbonyl compounds, we can use as a partial oxidizing agents here. Okay, and if you use if you want to convert alcohols into carboxylic acids, which we can use as a strong oxidizing agent. Interlink it is there. So chemistry is every chapter is interlinked to the another chapter. Okay, now we got the clarity. Okay, next. So reducing agent. Reducing agent. So what is meant with the reducing agent? So what is meant with the reducing agent means here the substance which it undergoes to the oxidation reaction. The substance which undergoes oxidation reaction. The substance which undergoes the oxidation reaction is called as here reducing agent. Okay, the substance which undergoes the oxidation reaction is called as here reducing agent. So is any example for the reducing agent which we know?
Concentrated NaOH and
concentrated
NaOH.
Concentrated NaOH does not act as a reducing agent, ma?
LiAlH4.
Sir, DALBH or something. I forgot.
LiAlH4.
Very good, ma. Lithium aluminum hydride. Next.
Anhydrous AlCl3.
Anhydrous AlCl3 won't act as a reducing agent. Is any other which we can use? So in organic chemistry, we are using as a MOSMA here. And D and F block elements also you studied some statement. Did you remember or not?
Sir, DIBALH.
Ma? Let us see, ma. What I'll tell means here. First, alkali metals. Alkali metals are they act as a strong reducing agent. Okay. So why alkali metals are they act as a strong reducing agents? Do you have any idea?
They are more reactive.
They are more reactive. So is any other reason? Is any other reason? Is any other reason, ma?
Lose electrons easily.
Very good, ma. So actually, alkali metals are they act as a strong reducing agent. So why they act as a strong reducing agents means here they are in greater in size. They have a low ionization enthalpy. They have a high tendency to lose the electron to attain the nearest noble gas configuration. Okay, so due to that reason only, so which they act as a strong reducing agents means here alkali metals and alkaline earth metals are they act as a strong reducing agent. Okay, sir, what is the best example we are using in the reducing agent means here? lithium aluminium hydride and sodium borohydride NaBH4. Along with that one, transition elements also we are going to study. So transition elements are, they act as a reducing agents. What are the elements that act as a strong reducing agents in the transition elements? Means here nickel, platinum, palladium. Did you remember? Zinc in presence of HCl, zinc in presence of ethanol, ETOH. So all these are, they act as a strong reducing agent. Okay, in this one, lithium aluminum hydride, sodium borohydrates are, we can call as a selective reducing agents. They act as here selective reducing agent. And nickel, platinum, palladium are, they act as a strong reducing agent. Okay, strong reducing agent. Okay, they can act as here strong reducing agent. Clear? Until here clear? If you're having any doubt, is any doubt is there until here? So what is the oxidizing agent and what is the reducing agent? Still anyone having doubt?
No, sir.
Okay, now so we had seen the oxidizing agent and reducing agent. But some compounds are there, they act as a both oxidizing agent as well as the reducing agent. Okay, some compounds are acts as oxidizing agent as well as reducing agent, Okay, some compounds are, they act as a oxidizing agent as well as here reducing agent. Sir, what are the compounds are, they act as a oxidizing agent as well as reducing agent? Means here one is hydrogen peroxide. Hydrogen peroxide, it act as a oxidizing agent as well as reducing agent. Another one is hydrogen sulfide. Hydrogen sulfide also, it act as a oxidizing agent as well as reducing agent. Okay, and sulfur dioxide also, it act as an oxidizing agent as well as here reducing agent. All these compounds are, they act as an oxidizing agent as well as here reducing agent. So now you got the clarity. Okay, sir, where we studied about all these components means here in D block elements you studied some concept. What is the concept you studied in the D block element? D and F block elements means preparation of the KMNO4 and their physical properties and chemical properties. Okay, and preparation of the potassium dichromate, the physical properties and chemical properties we studied under the D and F block elements. There clearly both the oxidation reaction and reduction reaction also be used as a hydrogen peroxide. Hydrogen sulfide also be used here, and sulfur dioxide also be used. Okay, while studying the chemical properties. Okay, there we studied about here all these oxidizing agents and reducing agents. Now we got the clarity. Okay, next one. Yeah. So before going to now, so we had seen this one. So before going to this chapter, what is the main important concept we have to know? Means here,
Sir, can you once scroll up?
Yeah. Ma, so this one I'll upload in app also, no problem. Don't worry. These notes, whatever I'm writing here, that I'm going to be uploading app. Slowly you can copy the notes later. Okay, just you listen, just you concentrate on the class. That is enough for me. Okay, hope so I'm going little bit fast because of, as per my knowledge, I want to finish the syllabus as early as possible. I want to recall main important chapters to you for the JEE examination. When you're having the JEE exam, when you're
From
having
April
JEE
4th to April 15th, sir.
April 4th to April 15th. So before that one, so can I explain important chapters here?
Yes, sir.
Okay, so then I'll do that one. Okay, first I'll finish this chapter. I think so. As per my knowledge, tomorrow I'm going to be finished this chapter. Okay, so because of interlink already it is there. Yeah, interlink already concentration terms are there, that already we studied in some basic concepts of chemistry. Okay, next. Right, man. I'll upload one. So this notes is I'm going to be uploading your app. Okay, next. So what is the main important concept we are having to find out the oxidation reaction, reduction reaction means first we have to know what is meant by the oxidation number. First, we have to know what is meant by the oxidation number. So, what is meant by the oxidation number, ma? Oxidation number is nothing but the charge present on atom. Okay, the charge present on the atom is called as a oxidation number. Okay, the charge present on the atom is called as a oxidation number. So if you see, polyatomic molecules are there. Okay, so in polyatomic molecules, so we are getting as a some charge. Okay, that is not the oxidation number. In polyatomic molecules, whatever the charge it is there, it is not the oxidation number. It is sum of the charges of atoms present in a molecule. Sir, what is the best example? Means, for example, whenever you're writing as a sulfate ion means you're writing as a SO4 2 minus. Carbonate ion means you're writing as a CO3 2 minus. Nitrate ion means you're writing as a NO2 minus. Okay, so NO2 plus it is a nitrosonium ion here. Okay, nitrate ion means NO3 minus. Okay, so like this, some charges we are getting here. Okay, so whenever you're having a polyatomic molecule, in polyatomic molecule, whatever the charge it is that is not the oxidation number. It is the sum of the charge of the atoms present in a molecule is called as a oxidation number. Okay, so to calculate the oxidation number, first we have to know some of the basic information. What we have to know means here, first we have to know some basic information. Sir, what is meant by the basic information means here, oxidation number, it may be positive, negative, or fractional also. Positive, negative, or fraction also my here. Okay, and sir, how we are getting as a positive, negative, or fractions means here, based on some basic information. Sir, what is that basic information means? All alkali metals. Okay, so what is the oxidation number of the alkali metals means we can take as a +1. Alkaline earth metals. Alkaline earth metals. So what is the oxidation number of the alkaline earth metals means +2. Okay, alkaline earth metals oxidation number is here +2. And 13th group elements, ma. Okay, so 13th group elements. So generally 13th group elements are, they exhibit as a +3 oxidation state and +1 oxidation state also. In this one, aluminium is, it exhibit as a +3 oxidation state. Aluminium is going to be exhibit as a +3 oxidation state. Okay, and 14th group elements. 14th group element general oxidation number is +4. General oxidation number of the 14th group elements is here +4. And 15th group elements. 15th group elements mean they exhibit as a +5 oxidation number. Okay, but if you see in this one, nitrogen is exhibit as a variable oxidation numbers. Sir, what are the variable oxidation numbers it is going to be exhibit means here? It exhibit as a -1. Okay, so -3 oxidation number also. Okay, and it exhibit as a +1, 0, +1, +2, +3, +4, and +5 oxidation number. So okay, so generally we can take as a -3. So which one we can consider means -3 oxidation number for the nitrogen. Okay, and if you see the 16th group elements, 16th group elements means everywhere we are getting as oxides. What is the oxidation number of the oxygen? General oxidation number of the oxygen means -2. General oxidation number of the oxygen is here -2. And sulfur also we can take as a -2 oxidation number. But in some cases, oxygen is exhibit as a positive oxidation number. In which one it exhibit as a positive oxidation number means here in oxyfluorides. In oxyfluorides, oxygen is exhibit as a positive oxidation number. Sir, what are the examples mean? In OF2, O2, F2. What is the oxidation number of the oxygen in OF2? Oxidation number of the oxygen in OF2 is, you will get as a +2. Okay, in O2F2 you will get as a +1 is the oxidation number. Sir, why you are getting as a +1? Here +2 means because of fluorine is electronegative atom. Highly electronegative atom in a whole periodic table. Fluorine, it always be exhibit as a -1 oxidation state. Fluorine, it always be exhibit as here -1 oxidation number. If fluorine, it exhibit as a -1 oxidation number means opposite one, it exhibit as a positive oxidation number only na. Okay, so in the given molecule, how many fluorine atoms are there here? 2 are there. If overall charge is will get as a -2, then opposite number will get as a +2 only na. Hence the oxygen oxidation number is +2. Okay, in this one O2F2. In O2F2 means here oxygen oxidation number is +1. It is there. Oxygen oxidation number is here +1. Now we got the clarity. And all halogens. All halogens are, they exhibit as a -1 oxidation state. That is a general oxidation number. Okay, that is a general oxidation number. Sir, how to calculate the oxidation number for some compounds which are important for JEE level examination? Okay, if you see JEE level examination means they ask one question. Previous year question, I'm asking here. Okay, so previous year I'm asking here. Sir, what is the oxidation number of Br3O8? Okay, what is the oxidation number of the bromine in Br3O8? Sir, how we can calculate the oxidation number of the Br3O8 in a molecule means here? First of all, the given molecule is neutral. For neutral molecules and the elemental form, overall oxidation number it becomes as 0. For neutral molecules, for the elements, overall oxidation number it becomes as a 0. Now in Br3O8 the oxidation number is 0. It is. Okay, this how we are going to be calculate means we can calculate. How we can calculate means first of all, how many bromine atoms are there? In a given molecule, how many bromine atoms are? Ma?
3.
Very good, ma. So that means I am writing as a 3x. We have to calculate the oxidation number of the 3 bromine atoms. Then we can write as a 3x. Okay. So what is the oxidation number of the oxygen? Now only I told.
-2.
-2. Total how many oxygen atoms are there?
8.
8. So overall charge, the given molecule is neutral. If it is given molecule is neutral means overall charge it becomes as a 0. Okay. Now we can simplify 3x plus. Okay, plus into minus you will get as a minus only now. What will you get? Plus into minus. Okay, so if it is minus means we can get as a 8 into 2.
16.
16. 8 into 2, 16 is equal to 0. Then if minus 16, if it comes this side means what happened? 3x is equal to
16.
plus 16. With 16 means here plus 16. Then what about the x? X is equal to plus
16/3.
by 3. So this is the one answer. This is one answer. Okay. Same question they're asking in different way in the mains level examination. How they're asking means here, what is the oxidation number of the each bromine in a Br3O8? That is the question. What is the oxidation number of bromine in Br3O8? What is the oxidation number of the each bromine? Okay, overall you will get as a 16/3 ma. Overall you will get as a 16/3. But they're asking individual bromine atom. What is the oxidation number of the individual bromine atom? That means first we have to know the structure. First, what we have to know, ma? We have to know the structure. If you know the structure means according to that one, we can find out the answer here. Okay, sir, what is the structure of the bromine? And same question also they asked in different way. What is the correct structure of the bromine? Br3OA. Okay, so writing this one, Br double bond O, 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 Br double bond O. So total 16 we have to divide into 3 parts. How we can divide means based on the oxygen. Now terminal oxygen, terminal bromine atoms are attaches to with how many oxygen atoms?
3.
3 ma. Each oxygen is containing -2 means what is the opposite number?
+2.
Ma, each oxygen is having -2. Here also -2, here also -2, here also -2. Total how much you will get? -6. If it is -6 means opposite number it has to be +6. Very good. Yeah. Okay. In this also. Here also we will get as a +6. And middle one. What is the oxidation number of the middle one?
+4.
+4. Now, what are the statement I had given? Either it is correct or not. Once you check it out, ma. In polyatomic molecule, the oxidation number is equal to sum of the charges present in a molecule. Now, how much you'll get as a 16/3? Now, here also +6, +4, +6. Overall charge, how much you are getting? +16 only, na?
Yes, sir.
Okay. So now you got the clarity.
Yes, sir.
I'm giving one question. I'll give one question. You have to solve that question here. Okay. Now, what is the question I'm giving? Simple one only I'll ask here. First of all, which you knows that one here. And HClO4. So what is the oxidation number of the chlorine in HClO4? Slowly you can calculate. Just 1 second, man. I'm getting a small call. Okay. Until that you can solve this question. You got the answer, all of you? What is the oxidation number of the chlorine in a given molecule? That is my question.
7.
Sir, is it +7?
Very good, ma'am. It is exactly +7. Okay. And now Samhita, what is the oxidation number of the chlorine in HClO?
+1.
Samhita. Okay. So which one? How much, ma'am?
+1.
Very good, ma'am. It is +1. Anyone you having doubt, me just you ask me, I will explain here. Okay. Next question. Next question. Okay. So one more question here. Here. Right. It's not right. Yeah. Right. That's yeah. Next, Shrita. What is the oxidation number of the sulfur in H2SO4? What is the oxidation number of the sulfur in H2SO? Shriyuta.
+6.
+6, ma. Very good, ma. +6. Okay. Next, what is the oxidation number of the sulfur in H2SO5? This also we can call as a Carose acid. Carose acid. This also we can call as here Carose acid. So what is the oxidation number of the sulfur?
+8.
Maximum oxidation number in whole periodic table is +8 only. The second highest oxidation number is +7. I will give the clarity about that one also. Which elements are they exhibit as a maximum oxidation number +8 means here? One is a xenon, another one is osmium. Osmium and xenon are they exhibit as a +8 oxidation number. Okay. And second highest oxidation number is +7. Which element is exhibit as a second highest oxidation number is manganese. Now, according to that one, you can say. According to that one, you can say either sulfur is exhibit as a +8 oxidation number. And one more hint also I'll give. Maximum oxidation number is equal to their respective group number. Maximum oxidation number is equal to the respective group number.
Sir,
Okay.
is it 7?
Come again, Nana. Whatever you are saying.
Sir, is it 7?
7 is not possible because of sulfur is belongs to the 16th group element. 16th group elements also we can call as a 6th group elements. 16th group elements also we can call as a 6A group element. 6A group. That means the maximum oxidation number of the sulfur is equal to 6 plus 6. Sir, how you are telling that it is plus 6? Okay. So actually, if you apply the formula, you are getting as here. How much will get as here? By applying the formula, hope so you may get as a plus 8. But it is not that. Okay. We can't find out here. Sir, how we can find out means based on the structure. Sir, how you are telling that structure means in a H2SO5, sulfur is attached with the two oxygens and one is present in the form of OH. Another one is present in the form of peroxide linkage. Okay, here also -1 oxidation state, here also -1, here -2, here -2. So sulfur is surrounded by -6. Then what about the oxidation number of the sulfur in the given structure means +6. Now we got the clarity, all of you.
So how do we identify the structures, sir?
Structure means based on the valence schema. Lewis dot structures. If you know how
Yes.
to write the Lewis dot structures means based on that one we can write. Got it?
Yes, sir.
Okay. So otherwise we have this question is there in 16th group elements. Groups also it is there enough for us. There we will get. So it is nothing but oxides of the sulfur, oxy acids of the sulfur. Okay. Can I give one more question? It is also JEE level question one. Okay. So and one more question I'm asking here. So let us see who's going to give the answer. H2S4O6. H2S4O6. What is the oxidation number of sulfur? Actually, here this one in this one, sulfur can be exist as a two types of the oxidation numbers. Multi-correct answer here. Okay, what are the oxidation numbers are exhibited by the sulfur in H2S4O6? Anyone?
5/2.
5/2. And to make you understand, I'll write structure here clearly. S double bond O, double bond O, bond S, bond S, bond double bond O, bond double bond O, bond OH, bond OH. Okay, Samhita, who's that one? So you told that 5/2 is the answer, na?
Yes, sir.
Okay, but in this one, if you observe clearly, means here terminal sulfurs are they exhibit as a +5 oxidation state. Okay, so whatever you had given answer is correct. Okay, but terminal sulfurs are they exhibit as a +5 oxidation state, and middle one is they exhibit as a 0 oxidation number. Because of whatever the electrons are there, those are not involving in the oxidation. Okay, each sulfur is having lone pair of electrons. That electrons are not involved in an oxidation number. So in a given molecule, total how many oxidation numbers we can observe means 2 oxidation numbers. What are the 2 oxidation number means? One is we can observe as a +5, another one is 0 oxidation number. Got it? Got
Yes.
it, all of you? Okay. And one more question, previous JEE question only. What is the oxidation number of the chromium in CrO5? It is also previous JEE question. And it is also previous NEET question also. What is the oxidation number of the chromium in CrO5? What is the oxidation number, ma?
+7.
Ma, now only I told that. +7 only manganese it exhibit as a +7. And halogens, iodine only it exhibit as a
6.
+7 oxidation state.
+6.
+6. How you are telling that, Samhita? Everyone, if you calculate, generally we can expect the answer. Expected answer is plus 10. Is it right?
So is it plus 2?
No, ma. Actually, this plus 6 is the correct answer. Plus 6 is the correct answer. Okay. But generally, we can expect the answer is plus 10. Sir, but how you got as a plus 6 is the oxidation number means we have to know the structure. CrO5 is having butterfly structure. Sir, how we can write the butterfly structure means Cr double bond O bond O here. So this side also bond O. It look like as a butterfly in here. So that's why CrO5 is having butterfly structure. Okay, in butterfly structure, wherever the double bond it is there, the toxin it exhibit as a -2 oxidation number. The remaining oxygens -1, -1, here also -1, here also -1. So if you add all together these numbers means you will get as a -6 is the oxidation number. Then opposite number it get as a +6 oxidation number only. Na? Javian.
Yes, sir.
Now you got the clarity how we got as a +6 oxidation number.
Yes, sir.
Okay. So actually in examination by seeing the question, everyone they can expect as a +10 is the answer. But +10 is the wrong answer. What is the correct answer means here? +6 is the correct oxidation number. So because of CrO5 it has here. So CrO5 is it has butterfly structure. Sometimes they're asking the question. CrO5 is having which kind of structure also? CrO5 is having butterfly structure. Now we got the clarity.
Yes, sir.
So
Yes, sir.
based on this one, so many examples they had given in your NCERT textbook backside based on the oxidation numbers. If you practice all that examples means that is enough. So those questions only repeatedly they're asking the mains level examination. If they ask the question based on the oxidation number means based on that only they're asking the question. Now we got the clarity, all of you.
Yes, sir.
Okay.
Yes,
So
sir.
Yes, sir.
remaining part will continue tomorrow. I think so. You're having the next class now. At what time you're having
Yes,
class
sir.
here?
8:35.
8:35. Okay. Actually, next, what is the next concept we are having means types of the redox reactions are there. Based on that one also, they're asking the questions in the mains level. Okay. I had seen some previous questions. If you see the previous questions also means here, based on types of redox reactions also, they're asking some questions. Okay. Clear? So that part I'm going to be continued by tomorrow. Tomorrow I'm going to finish this chapter. So only two things are there. So one is this one, types of redox reactions. Another one is balancing of the equations. Okay, if we finish that balancing of the equations and it all means here, then chapter is finished here. Because of we already seen the calculations. Which calculations and it all means here? So normality, molarity based. If we are having any time means we'll discuss that kind of questions. Okay. Right, ma? So we'll continue tomorrow. So thank you all.
Thank you, sir.